Hello, everyone. This is Thomas, and I welcome you once again to another session of Exploit Tutorial. Exploit Tutorials, learning made easy. So, please, before we proceed to the solution of this particular question, I would like you to support my channel by subscribing, liking, and sharing with your friends so that they can also benefit from whatever we are doing on this channel. Now, this is a basic mechanic problem, and this is a problem under 3D resolution of force or resolving forces into three components. That's the S component, the Y component, and the Z component. So the S component, some problems, you have the S component here, Y component here, and Z component here. It can be changed, the positions. Very good. So when you see it like this, don't be confused at all. Now the question says, we should express the force F as a Cartesian vector. Now in order for us to express this force as a Cartesian vector, we will have to find the S component of the force, the Y component of the force, and the Z component of the 100-pound force. So let's go into the question and analyze it. So over here, we have a force that is being placed at the side of the Cartesian plane, and this force makes an angle of 60 with this particular axis. Now, in solving of 3D problems, what we do is that we resolve forces into two components at a time. So this force being placed in space, if we want to resolve it, we have to resolve it into a Z component and another component before we can resolve it from that component to all the other components. And this component here, or this particular axis here, is our imaginary axis labeled H. So H is our imaginary axis. So over here, what we can redraw this one as, we have our Z here and we have our H here. So this is the particular force we are talking about. That's the 100-pound force. So the angle between the H and the force is 60 degrees. So you see we have only two components here. That's the Z component and the H component. So let's resolve the force into Z component and H component. So FZ will be equal to 100 sine 60 degrees. I hope you agree with me. Why sine? Because the Z will be opposite to the angle 60. So it will take sine. And this will give us 86.6 pounds. Very good. Now let's come to our FH. FH will be equal to 100 cos 60 degrees. So this one will give us 100 cos 60 degrees will be 50 pounds. Very good. Now that we've been able to calculate for our H components, you realize that H component lies between the X and the what? The negative Y. So this is the Y. So the opposing axis to the positive Y will be our negative Y. So H also lies between X and the what? The X axis and the Y axis. So what we do is that we resolve the H into S component and into what? Y component. Please, I hope you are with me. Very good. So Fx will be equal to Fh. Will it take, so Fh, so as we have our Fh here, the angle between the angle between the H and the X is 45 degrees. Please, I hope you can see it from here. So this is the H, right? So angle between the H and the X is 45 degrees. So realize that the angle is adjacent to the X. So the X will take the cos of the angle, which is 45 degrees. So Fx will be equal to 50 cos 45 degrees. And this one will give us 35.36 pounds. Very good. Now, let's calculate for our Fy. Fy will be equal to Fh sine 45 degrees. But remember that Fy is, when we resolve the H, it will lie to the negative y axis, so it will take negative. So Fy will be equal to negative 50 sine 45 degrees. So Fy will be equal to, so if you find negative 50 sine 45, it will give us negative 35.36 pounds. Now the question asks us to calculate for, express the force F as a Cartesian vector. So F in a Cartesian vector form will be F bar, which is equal to Fx I plus Fy j plus Fz k. So F in a Cartesian vector form, we have our Fx, which is 35.36 I plus our Fy, which is, so over here, since Fy is minus, so it will be minus 35.36 J, and finally we add our Z, which is plus 86.6 K. So we realize that we didn't add the H because the H was an imaginary axis, which helped us to calculate for our X and the Y component of the force. Thank you very much for joining us once again, and hope to see you in our next video.